You gonna verbalize stuff, or did you send me anything?
No, I'll verbalize everything I can, and then. All right. So we were doing this question that was find all the complex solutions. So it's 2x squared minus 3x plus 5 equals 0.
Okay. If we want to solve that, and if we already know that it's going to require complex solutions, then just let's go into the quadratic formula. Well, hold on. In other words, if we thought it might have real solutions, it might be worth a little bit of effort to see if we could factor it.
Okay.
But if they tell us that it's got complex solutions, then we know we can't factor it. So let's put it into the quadratic formula. What's the quadratic formula?
What'd you say? What was the last part?
What is the quadratic formula?
Negative b plus or minus the square root of b squared plus minus 4ac over 2a.
Good. And that's one you got to remember. That's not going away. So what's A, B, and C?
A is 2. B is negative 3. And C is 5.
All right. So now plug in everything.
So so it's 3, positive 3. So I'll do the plus. Oh, we could do it at the same time. Plus, minus, square root of 9. Minus 4 times 2 times 5 over 2 times 2.
Okay. Now, the first thing you always want to simplify is what's under the square root.
Okay, so that's 3 plus or minus the square root of 9 minus 40, which is negative 31.
Okay. Now, can that negative 31 be simplified at all? Can it be factored first?
No.
Okay. So how do I express it in terms of a complex number?
In terms of a complex number, it would be this would be I times the square root of 31.
Correct. And usually we write that like that. It would make more sense to write it the way you said it.
Okay.
Because when I write it like this, there's always the confusion as to whether the I is under the radical sign or not.
Right.
And it is.
But you write I afterward?
Well, no, you just never see I times square root of 5. That's not the way mathematicians write it. They write square root of 5 times I.
Okay.
Okay? In other words, the standard format for a complex number is A plus BI. So the coefficient of the imaginary term is always in front.
Okay.
Okay?
Yeah.
Now, that means there were two solutions. 3 plus root 31i over 4 and 3 minus root 31i over 4. Now, it also matters as to whether or not they requested your answer in standard format. Did they?
No, it just says find all the complex solutions. If there's more than one solution, separate them with commas.
All right. So if we do that, then we've got two solutions. this one. And this one. And in fact, according to his instructions, this is the way we have to give it. Okay?
Okay, so over 4, then 3 minus.
Yeah. Now, let's say he wanted it in A plus BI format, which is that standard format. We would need to separate this into two fractions.
3 over 4.
Plus root 31 over 4I. And this one is 3 over 4 minus root 31 over 4I.
Right, okay.
In other words, you want a real part and you want an imaginary part. So this would be 3/4 plus root 31 over 4I, where A is 3/4, B is that. All right, what else you got?
All right, so this says compute the value of the discriminant and give the number of real solutions of the quadratic equation.
Okay. First of all, this is the discriminant. The part that is under the radical sign.
Yeah.
Not with the radical, but just this part right here.
Okay.
There's lots of reasons why that's your first step sometimes. It's very useful to know whether the discriminant is greater than 0, less than 0, or equal to 0.
Okay.
So what's the function? That previous one, or?
No.
Okay.
So it's negative 9x squared minus 9x minus 4 equals 0.
Okay. So if it would be nice, before I plow into trying to solve this thing, it might be kind of nice to know what b squared minus 4ac was, because that's going to tell us whether there are two real solutions, whether there are two imaginary solutions, or whether there is exactly one real solution. That's the only three possibilities you got. And it depends on whether this number, the discriminant, is greater than 0, less than 0, or equal to 0. So what is it in this case? What is b squared minus 4ac equal to?
81 minus, it's negative. 81 minus 144, which is negative 63.
Hold on. All right. A lot of times with these problems, it's really easy to make a mistake because you're staring at a lot of negative signs. That negative sign means subtraction. That's a negative 9, that's a negative 4. So it would be extremely easy to make a mistake here. So what I generally tell everybody is do that first. Okay?
Okay.
When you did that, you got plus 144, right?
Yeah.
So
then you subtract 144.
Right. So it's 81 minus a plus 144, which gives you negative 63. So that is the discriminant. So what does that tell you about the solutions? There's either, remember, there's only three possibilities. There's two real, there's two imaginary, or there's one real.
If it's less than 1, then there's one real, right?
If it's 0, there's one real.
Okay.
If it's positive, there's 2 real. If it's negative, there's 2 imaginary. It's exactly how you would think. Since,
Okay, so positive is 2 real,
right.
and negative is 2
is 2
imaginary.
imaginary. And exactly 0, notice what you get if it's exactly 0. If that's exactly 0, there's no plus or minus, and this is your answer. And minus b over 2a is going to be a real number.
Okay, that makes sense.
So
But it's
if the discriminant is exactly 0, you're only going to end up with 1 answer. But if it's greater than 0, you're going to end up with 2 real.
A positive and a negative.
Yeah, if it's negative, then we're going to be taking the square root of a negative number. So we're going to have 2 imaginary solutions.
Okay, that makes sense.
And occasionally, rather than go ahead and work out all the math of solving the quadratic formula, if you knew that the solution was going to be imaginary, you might not have to do that. So
wait, I'm sorry, the question says, give the number of real solutions of the quadratic equation, so it's 0.
Correct.
Okay.
How many imaginary solutions were there?
2. Imaginary solutions always come in pairs.
There were 2, exactly. Because there was the plus and there was the minus.
Okay. So, okay, so the length of a rectangle.
Okay.
Should know how to do this, but let's just do it. The length of a rectangle is 3 yards less than its width.
It's what?
3 yards less than, 3 yards less than twice the width.
Hold on.
So,
now, that can be a little tricky to write.
Less than
Make
twice
sure you understand that's how you write that.
2w minus 3.
Yeah, in other words, despite the fact that the 3 was the first thing in the sentence, they always do that.
Right. Now the area...
They always use less than, which means the 3 is going to be the last thing in the sentence, not the first.
Okay.
This is what 3 less than twice the width means.
Right.
Okay?
And then, so the area is 27 yards squared.
Okay.
Okay, so the area, so it's 2w minus 3 all times w equals 27.
Well, yeah, you skipped a couple steps here. First of all, area is equal to what?
Length times width.
Okay. So there's our equation. In fact, we have 2 equations. We have 2 equations and 2 unknowns. Well, there's 2 ways to solve these type of equations. There's substitution and there's elimination. Well, substitution usually works best if one of the equations is fully solved for one variable, like this first one is.
Okay.
You've got L equals 2w minus 3. So it's really easy to substitute that into the second equation. So the second equation is 27 equals LW. Well, instead of L, I'm going to write 2w minus 3.
Right.
Multiply that by W. Now we're looking at one equation and only one unknown. That means we'll be able to solve it. Might be difficult, but we're going to be able to do it. Whereas if I have one equation and 2 unknowns, there's an infinite number of solutions. In other words, both of these equations by themselves would not allow you to be able to solve this. But as long as I know that both of them are true, then I can proceed.
Okay.
Now, how do you proceed?
Well, you multiply the W. You distribute the W.
Okay. So what do you get?
So you get 2W squared minus 3W equals 27.
Okay. And now what?
Now you can add 3W to both sides.
No, what we're looking at here is a quadratic.
Oh, so you want to subtract 27.
Exactly. A really good thing to be able to do in math is when you see a quadratic, you know that you got to have 0 on one side and everything else on the other. So
Okay.
I'm going to subtract 27 from both sides. That leaves 0 over there. And that's the form you got to get it to solve it. That's pretty much the only way to solve it. Now, if I didn't have a W term, there's other ways to solve it. But this always works. When you have a quadratic, always get everything on one side, 0 on the other.
Okay.
Now, and the reason that's powerful is because if I can factor that, if I have two terms multiplied together that are equal to 0, then I know one of those terms has to be 0. So I can make progress on this if I can separate this quadratic into the product of two linear terms.
Okay.
What's the first step in trying to factor that?
Separating the W's?
Okay, they only separate one way. That's that way.
Right.
The next step in factoring.
They're going to be two different
Good.
signs.
That's definitely the next step. In this case, plus minus is not the same as minus plus.
Right.
Allow for both of them by writing it like this. Now, the next step is factors of 27. That's all I know. I can't say they have to subtract to 3. I can't say they have to add to 3. Because all I know is I'm going to need factors of 27. Well, there's
So
only 2.
3 and 9.
That's it. Those are the only two sets of factors. So which one would I start out with if I was trying to do this by trial and error, and I'm just going to try all combinations? Which
You want those that are closer together.
Yeah, 9 and 3.
Right.
Okay, and my goal is I got to produce that as a middle term. So clearly a 9 next to the negative sign and a 3 over there isn't going to do it. But
Right.
9 there and a 3 there comes closer. Well, what do I get for a middle term if I do it that way?
You'll get a middle term. You'll get 9W and 9.
Minus 6W. In other words, the middle term always comes from the two inside terms multiplied plus the two outside terms multiplied. That's what my double smiley face means.
Okay.
Okay? That adds to plus 3W. Well, that's not our middle term.
So switch the signs.
It's the right number, exactly. So all I have to do is switch signs. I got to put the 9 with the negative, and I got to put the 3 with the positive. That automatically switches signs on these terms and switches signs on that term. So we do end up with minus 3W. And that's pretty much how you factor these more difficult ones. It's a trial and error process, and you just keep kind of trying it until you find a combination that produces your middle term. Now, notice I didn't check the first term because I don't need to. I know that 2W times W is 2W squared. And I didn't check this term because I know that the way I arrived at these numbers, I don't need to check that term. I know that minus 9 times plus 3 is minus 27.
Right.
One term that's tough is the middle term.
Right.
It's always the term that's in doubt. Okay? So now that I've factored it correctly, and I want to set that equal to 0, what are the answers? What's W equal to?
W is equal to -3.
Okay, that's 1W.
-3. W is equal to
Set that equal to 0. That's always how you do it.
So 9/2.
Yep. In other words, what the fundamental law of algebra tells us is that if I multiply two numbers together and they're equal to 0, one of them has to be 0. Not necessarily both of them. One of these two solutions has to be true.
Okay.
I don't necessarily know that both of them are true. In this case, they are both true. If I go back in and I plug in both of these for W, I will find the original equation works.
But because we're talking about length and width, which can't be negative, you have to use 9/2.
Exactly. And there's all kinds of other situations where that happens. It's not just when you're doing geometry and coming up with measurements. A lot of times if you have radical signs, you'll have one of these solutions doesn't work. Or if you have the three situations that I always look for extraneous solutions are radical signs, absolute value signs, and logarithms. Whenever you have any of these three, and then I guess a fourth one would be dimensions. In other words, all four of those types of problems, a lot of times you come up with two solutions because quite frankly you almost always get two solutions when you're solving a quadratic. And frequently one of them is called extraneous, which is okay. Like I said, both of them don't have to be 0. One of them has to be 0.
Right.
Well, in this case, since we're talking about a dimension of a rectangle, well, the -3 clearly can't be correct. So the only solution is W equals 9/2. Now, you still have to go back and solve for L.
L. Well, then you just plug in, and you get 6.
Yeah, exactly. So L equals 6. So 6 by 9/2 is the dimension of that rectangle. Right? What else?
Okay, so this is a solve for y.
Okay.
Y plus 15 over y equals -18.
I'm not quite sure I heard you from the start. What is it again?
Y plus 15 over y equals -8. Just the 15s over y.
Okay.
Yeah.
What's the best thing to do on these kind of equations as a first?
Multiply both sides by y.
Yeah. In other words, get rid of the denominator. Denominators just give us problems. They make equations hard to solve. So if you can always get rid of denominators as a first step, it's going to produce an equation that's easier to solve. So if I multiply everything by y, what do I get?
Y squared plus 15 equals -8y.
Okay, now what?
So you're going to add y. You're going to add 8y to both sides.
Put it in the right place.
Then you're going to factor.
How does that factor?
Y plus and y plus. It has to add to 8 and multiply to 15.
Exactly. It has to add to 8 because of that plus sign.
So it's 3 and 5.
Yeah. If that was a minus sign, then it would have to multiply to 15 and subtract to 8.
So y equals -3 and y equals -5.
Yeah. And this was not any kind of a dimension problem, right?
No.
So as far as we know, both of those answers are correct.
They can be positive, yeah.
Yeah, and if you were to stake your life on it, you'd want to check both of them, right? Somebody said, are those the two correct answers, and would you bet your life on it? Well, let's test at least the -3. So we got -3 plus 15 over -3. Is that equal to -8? Yes, it is.
Yeah.
Okay, and the other solution was -5. So we got -5 plus 15 over -5. Is that equal to -8?
Yes.
And it's yes. Now, typically when you have polynomials, I'm not sure I've ever found one where one of them didn't work. In other words, where you have extraneous solutions. They don't come from these kind of equations. They come, like I said, when you have a radical sign in the equation, or if you have an absolute value sign, or if it's a logarithmic equation, or if it's a measurement. This is none of those. So we would not expect an extraneous solution here. We would expect both solutions to work. And in fact, if I was taking a test, I would not try either one of them. I would just assume that both of them worked.
Right.
As opposed to if there was a square root in there, then I would try both of them to make sure they both worked.
Okay.
Okay?
Okay. So now this is solved for v. So 1 equals the square root of 3v minus 9 minus 2.
Okay. First thing we should be aware of is that we may end up with an extraneous solution because we're looking at a radical sign.
Okay.
What's the first thing you want to do here?
Add -2 to the other side.
Add 2 to both sides.
Right, sorry.
Now what?
3 equals the square root of 3v minus 9.
Next step?
You could square both sides.
Next step?
9 equals 3v minus 9. Then you can add 9 to both sides.
So I get one solution. V equals 6. Whenever you just get one solution, well, that's probably going to be, it's not going to be extraneous. In other words, I don't even have to check this. We get 8 minus 9, and the square root of 9 is 3. 3 minus 2 is 1. Everything's copacetic.
Right.
If I would have got 2 solutions somehow, in other words, if this turned out to involve a quadratic that you had to factor and stuff, then make sure you check both solutions.
Okay.
All right.
This one is the absolute value of w plus 2 minus 25 equals minus 13.
First step?
Add 25 to both sides.
Now, what does this mean? It means 2 different things. What are they?
It means positive w plus 2 equals 12.
Actually, the first statement is exactly what you're looking at without the absolute value sign.
Right.
Or
the whole thing negative. So negative W minus 2.
No, never change what's inside. Always leave it this unadulterated. What's changed is the other side. Understand?
So negative 12. Okay.
In other words, you never change what's inside there for the first statement or the second statement. It's W plus 2, both places.
Okay.
No matter how complicated it is, it does not ever get changed. The only thing that's different is the first one is 12, the second one is minus 12. So now solve each one vertically.
The first one is W equals 10. The second one is W equals negative 14.
And now let's check both of them. 10, the absolute value of 12 is 12. Minus 25, that's minus 13, so that works. Minus 14 plus 2, that's minus 12, the absolute value of which is 12. Minus 25 equals minus 13, that one works. So, just because you have an absolute value sign doesn't necessarily mean you're going to have an extraneous solution. In this case, both solutions are valid.
Okay. So x minus 5x to the 1/2 power plus 6 equals 0.
This is what I call a quadratic in disguise.
Okay.
It doesn't look like a quadratic because it's not x squared. But technically, really, a quadratic is any time this term is the square of that term. And
right, and it is.
1/2 squared is x. So we're really looking at a quadratic. Now, a lot of times it's easier if you use a method called U substitution. And I'll show you why. I'm going to let u equal whatever that middle term is, x to the 1/2. Okay?
Okay.
Now, u squared becomes x, and I can write this whole thing in terms of u. In other words, I can write it as u squared minus 5u plus 6 equals 0. Now it looks very much like a regular quadratic. You would factor it into u minus 3, u minus 2 equals 0. So you get u equal 3, u equal 2. And remember, u was square root of x. So I get square root of x is 3, square root of x is 2. Square both sides, I get x equal 9 and x equal 4. So I get two solutions. You see how I got all of those?
Yes, 9 and 4. Yeah, that makes sense. So you're substituting u
for x
as
to the 1/2.
Okay, that makes sense.
Well,
and you could do that even if it was larger, like if it was x to the 4th
x to the 4th,
minus,
and that could be x squared. Then
right.
Technique, as long as this is the square of that, then you can use this technique.
Okay.
If I had e to the 2x minus e to the x minus 2, same thing. That's a quadratic in disguise. In other words, the e to the 2x is the middle term squared. And I would let u equal to the middle term, which makes u squared equal to e to the 2x. Then I would just substitute, and I'm looking at u squared minus u minus 2. Well, I can factor that real easy, and then go back and resubstitute.
Okay.
So always be on the lookout for quadratics in disguise. And they can be in the form of trig functions, exponential functions like e to the x, or these kind of functions. This is not even a polynomial because you got to do the 1/2. But it's still a quadratic in disguise. And the easiest way to look at them is with this U substitution. Now, do I need to do U substitution? No. I could immediately, in other words, forget about U substitution. I don't need that. I'm going to go straight in, and I'm going to say this is the square root of x minus 3, the square root of x minus 2. Notice that produces x. When I multiply those two together, it produces x minus 5 square roots of x plus 6. Exactly what we started with.
Right.
And I get to the solution immediately. Square root of x equal to 3, therefore x equal to 9. Square root of x equals 2, therefore x equals 4.
Okay.
And I believe that both of these work. 9 minus 5 times 2 plus 6, excuse me, 9 minus 5 times 3 plus 6 indeed equals 0. And the other solution is 4 minus 5 times 2 plus 6, which also equals 0. So both solutions are valid.
Okay. Okay. I know how to do this, but let's refresh. So it's a compound inequality.
Okay.
You have to graph it on the number line. So 4x plus 3 is less than or equal to negative 13, or 4x plus 1 is greater than 13.
All right. So what we're going to do is graph both of these. In one case, we're going to use a solid line, the top one. In the other case, we're going to use a dotted line. And then we're going to figure out what regions on our XY plane are satisfied by both of these.
Okay.
So, how do I graph that one?
Well, you got to solve. First, you got to solve it as if it was an equation.
Yeah, my mistake. This is not two variables. This is one variable only. We're not going to graph it on the XY plane. We're going to graph it on the number line.
Yeah.
All right. So first, let's solve it. Solve the top one. What is x?
Negative 4. Well, x is less than or equal to negative 4.
Good. And the bottom one?
X is greater than 3.
So it's an or. So x is either less than or equal to negative 4. That means a solid dot.
Going down.
Going left.
And then 3, an open dot on 3 going up.
Going right. Not up.
Yeah.
Right. In other words, we're on a number line. We can only go left or right. When you have one variable, that's always the way it is. If
I meant up and down.
Y in here, then I would be on the XY plane.
Right. I meant up in value.
Yeah. Okay. I see what you're. Okay. I got you. I've been spending too much time with vectors. Vectors, up is positive, down is negative, to the right is positive, to the left is negative. So I'm keenly aware of up, down, left, right. All right. What else you got?
So this is the same thing. Graph the solution of the inequality.
Okay.
The absolute value of w minus w minus 2 is less than 3.
All right. First of all, let's take this situation. What does that mean?
That means positive x is less than 3, and negative x is less than 3.
Nope. Never change what's inside.
X is less than negative 3.
Well, you got to change both the direction and the sign.
Oh.
So that's always what it means. In other words, when you have absolute value and an inequality sign, it means these two things.
Okay.
Okay? So in our case, what does this mean?
W minus 2 is less than 3. Or W minus 2 is greater than negative 3.
Perfect. And now it becomes fairly straightforward.
W is greater than 5. W is less than 5, or W is greater than negative 1.
Now, these are both open circles. And it's this region in here. Now, this can get a little tricky. When you have this absolute value, it definitely means this is an OR. It's not an AND.
Okay.
However, if they were to give you a problem that says W is less than 5 and W is greater than minus 1, notice that that is the real number line, the entire number line. W is greater than minus 1 goes all the way there. W is less than 5 goes all the way there. You end up covering the whole number line. So there is a big difference on whether you use the words or and.
So with or, you only do the space in between?
Yes.
Okay.
And when you have an absolute value inequality, it's always an or. It's never an and. It's always an or.
Okay.
For you to get an and, they would almost have to spell it out. They would have to say W is less than 5 and W is greater than minus 1. Well, that covers every number, right?
Right.
In other words, 100, that's greater than minus 1. But
Right.
if it's an or, then it's strictly the place in between. Although, boy, that almost seems like that's backwards. Seems like it when it's or, it should be the whole number line. That's not the way it is. So, and you may not ever get a problem with and in it. In other words, when you're starting with an absolute value inequality, it's always or, and or is always just the place in between.
Okay. Unless if they don't overlap, then it's just whatever it says.
Well, the only other solution could be this, where it's greater than 5 and less than negative 1, in which case it would go that way
And the other way.
that way.
Yeah.
In other words, it's either the outside place or the inside place
Right.
when it's an or.
Right. When it's and, it could be both.
It's only difficult when it's an and, but you may not ever even get any and problem.
Okay. All right, so this is a calculate the distance between 2 points problem.
Okay.
So it's between point K, which is -8, 9, and M, which is...
Hold on, yeah. I thought you were giving me the x dimension was K. -8, 9, and what's the other point?
-1, 4, which is M.
Now, the thing to remember about the distance formula, it's the Pythagorean theorem. That's all it is. In other words, if I have 2 points and I want to figure out the distance between them, that is the hypotenuse of a triangle that I would draw.
Okay.
And notice the triangle. This is delta x, the difference in the x coordinates. This is delta y, the difference in the y coordinates. And d, the distance, is going to be the square root of delta x squared plus delta y squared, which turns into the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So once you know the formula, then the rest is trivial. But always remember the distance formula, that's the hypotenuse of a right triangle. Once you remember that, then you'll always remember what it means.
So it's 8, negative 8 minus 1.
No. Now,
minus 1.
That's a huge difference. That's
right.
One of the most common mistakes I see with students is dropping a negative sign. Particularly when you're subtracting a negative number. Everybody wants to drop one of those negative signs. And it's huge. It's going to give you the wrong answer. So the only thing I can say is that when you're doing these things, spell it out always. It's negative 8 minus negative 1. When you spell it out and then simplify, it becomes negative 8 plus 1. If you try to do the entire thing, it frequently becomes this. And that's not the same number.
No, it's not.
Okay, so...
And it's that whole expression squared.
Yes. Well, that's the x squareds. So that's
right.
minus 7 squared. Just
and then 9.
49. And then
minus
4 is
squared.
5 squared is 25. So I want the square root of 49 plus 25. Now these are always going to be positive numbers. And because I'm squaring. So even if it's a negative number, it turns positive. And what that means is in my distance formula, I can actually do these in whatever order I want. I could do x sub 1 minus x sub 2 squared. Notice that's always going to be the same as x sub 2 minus x sub 1 squared.
Right.
And I could do this in the other direction. In other words, I don't even have to do them in the same direction like you do when you're doing slope. When you do slope, you can also do them in either direction, but you have to do them in the same direction in the numerator and the denominator. When doing the distance formula, you can do them in whatever direction that makes it easiest. So it's easiest going 9 minus 4 and probably minus 8 minus a minus 1. But sometimes it'll be particularly easier. Let's say you had these 2 points.
So the square weight, I'm sorry, for this question, the distance is the square root of 74.
Correct.
And it says give an exact answer, not a decimal approximation, so that's the closest thing.
Yes. The only thing is, can you simplify the square root of 74?
Well, yeah.
No, you can't.
You can't? You can't take it?
Nope.
Oh, no.
There would have to be a factor of 74 that was one of your perfect square numbers. 4, 9, 16, 25, 36. None of those are factors of 74.
Okay.
I cannot simplify square root of 74. I can turn it into a decimal approximation, but the reason they say give an exact answer, that's an exact answer. Now, if I could simplify it, I would. You know, if I could pull some sort of a whole number out. In other words, if it was the square root of 72, well, that's the square root of 8 times the square root of 9. Well, that's root 2 root 2, and that's 3. So this whole thing becomes 6 root 2. So
Right.
I can simplify square root of 72, but I cannot simplify square root of 74. It's not just a question of finding factors. Let's talk about that. Square root of 10 does not simplify. Even though it's equal to the square root of 5 times the square root of 2, none of those produces a whole number.
Right.
So that's simplified.
But if it was the square root of 75,
then that's the square root of 25 times the square root of 3. That's a whole number.
5 times,
Yeah.
5 times the square root of 3.
So the only time you simplify it is if you can pull out a whole number.
Right. Okay, so we'll do one more before we take a break.
Take a little break.
So this is find the midpoint.
Okay.
Sorry, let me just box this in because I'm taking notes. Midpoint.
This is actually very easy. Just give me
So the point
any 2 points.
points are 1, comma, -8 and -5, comma, -4.
The midpoint is going to be the halfway point between the x coordinates and the halfway point between the y coordinates. Now, how do you get the halfway point between the x coordinates? You add the two numbers and divide by 2. What do you get?
Sorry, let me just
add 1 to -5 and divide your answer by 2.
Okay, so you add 1 and -5, which gives you -4.
Okay.
Then divide it by 2, and that gives you -2.
And you can see that that's the midpoint. That is 3 units away from 1, and it's
And
3
3
units away from -5.
Okay.
Do the same thing
Then,
with y coordinates.
so you have -8 plus -4, which is -12. Divide by 2, you get -6.
And that clearly is in the middle between -8 and -4.
Okay.
But it's always that simple. You add the 2, divide by 2. No matter what the 2 points are, it does not matter.
Okay.
Okay? How long? You want a 15-minute break? 10-minute break? What do you feel like?
Yeah, I'll do a 15-minute break.
I'm just going to leave everything open. I'm not going to close out, go to meeting.
All right, we'll just mute it.
I'll stop the recording. Start this recording. Let's get back to what's next after distance between 2 points. Oh no, that was the midpoint.
Yeah, we did midpoint and we did distance between points.
Right.
So this is a find all values of x that are not in the domain of G.
Okay.
So it's G of x equals x minus 8 all over x squared plus 8x minus 9.
All right. Despite how they worded the problem, what they really are saying is, what is the domain of this function?
Okay.
And usually when they ask you what the domain of a function is, it is all real numbers except for certain ones. Well,
right.
The number one...
And certain ones are the zeros in the denominator.
Exactly. So factor that denominator.
So it's separate the x's, it's x and x. It's going to be
Plus minus.
All right, plus minus 1 and 9. -1 and
9's
9.
going to go with the plus because the middle sign is plus. So, what can x not be?
X cannot be -9 or +1.
Now, do they have a particular way that they want you to give the answer? There's various ways to give the domain.
It says x equals.
You could say all reals except x not equal to that, or you could give interval notation. Are you familiar with interval notation?
Yeah.
Which one do they want you to use? Do you know?
I don't think it's either, actually. I think they just want me to list the values of x that are not in the domain, so just write the answers.
Right there. That's all you need.
So -9 and +1.
+1. Any other value of x is in the domain, including x equal 8. There's nothing wrong with the numerator being 0.
Right.
You just can't have a 0 denominator. Okay?
Right. Okay, so graph the function f. The graph of the function f is shown below. Find one value for x, which f of x equals 4, and find -2. Should I send this to you?
Probably. It's the one thing you can't hardly verbalize is
Graphing.
graphs. If they're wanting you to interpret a graph.
I'd also like to apologize for my Google profile picture. I didn't realize which email I was to you.
I didn't even notice. Oh, yes,
Okay.
you did. It was Fat Albert, not Fat Albert. What's that character's name? It was
Fat
Mike.
bastard.
Fat Bastard, yeah. Mike, wasn't that Mike?
Yeah, Mike Myers.
Mike Myers, yeah. I haven't seen that picture in a long time. So I did take notice when I saw it.
Let me figure out how to send this. There we go.
Tell me when it says sent on your end.
It says sent.
All right, what does it want you to? Okay, hold on, let me read it 1 second. So, what's one value of x for which f of x equals 4?
One value of x for which f of x equals 4.
F of x is the same as y.
Right. So when f of x equals 4, it already does equal 4.
At what value of x does y equal 4?
0.
Okay, right there. So that's the answer, 0. And now find f of -2.
F of -2 occurs at 2.
Correct. In other words, there's -2. That's the value at -2. And I guess they want you to put those answers in here, which I won't do, but you can certainly do it on your end.
Yeah.
Okay. What else?
So wait, I'm just writing this down. F of x equals 4 at 0. Okay, next. Another word problem.
Okay.
Let me see if we could just verbalize this one. Jenny is driving on a highway.
Okay.
She uses 1 gallon of gas for every 40 miles she drives.
Okay.
The distance, d, in miles she travels on gallons of gas is given by the following function. D of G equals 40 times G. How far does Jenny drive if she uses 2 gallons of gas? So you just plug in 2 for G, right?
Yep.
So it's 80?
Uh-huh.
80 miles?
Uh-huh.
Oh, that was very easy. Okay.
It was very easy. Especially with a problem that you can relate to because you've driven a car probably.
Yeah.
You know that if you get 40 miles to the gallon, which is the way that's usually expressed, not 1 gallon per 40 miles, but 40 miles to the gallon, well, you're going to get 80 miles on 2 gallons.
Right. Okay. So, domain of a function is the x to x, right?
It's the allowable x values. For example, if I gave you this function, what are the allowable x values?
Anything above 0. Anything above -1.
No, greater than or equal to 0.
Greater than or equal to 0.
Can't quite say greater than -1 because you could not make it -1/2.
Right. Okay.
In other words, it's got to be a 0 or a positive number. That's it. So
Okay.
that is how I would describe the domain if I had this function. Now, if
you were looking at a graph,
if I had the following function, close, but here x has to be greater than 0 because I cannot even let it be 0 because that means I would be dividing by 0.
right? You can't have 0 in the denominator.
Right.
So if you were looking at a graph,
Uh-huh.
and let's say it spanned from -3 to 3 on the x-axis,
Okay.
that would be the domain, -3 to 3.
Yeah, I mean, you mean if you had a graph that was like this.
Right.
Yeah. The domain.
But if the -3 was not filled in circle, then it would be negative. What would it be?
Be an open circle.
Yeah.
It would be this. In other words, the way I have drawn it, it's bracket -3 to bracket 3. My curve, -3 is okay, +3 is okay.
Okay.
If I wanted it to be an open circle, then I would use parentheses.
So if you had if the -3 was an open circle and the +3 was a closed circle, it would be parentheses -3,
Correct.
comma 3 bracket.
Correct. And parentheses always go around infinities. You can never have a bracket around an infinity.
Right, of course.
Because that indicates that it's a number, and it's not. It's a concept.
And so the range is on the y-axis.
Correct. In this graph I've drawn right here, the range is from between my 2 horizontal lines. Well, not quite. There's the minimum value. There's the maximum value. So that's the range right there.
Okay. -4, 2, 4. Okay. So this is find the slope of a line passing through 2 points.
Okay. Classic algebra problem. The equation of a line, and they give you 2 points that are on that line.
It's not giving me the line though. It's giving me the 2 points.
That's fine, but that's the classic problem, is when you get 2 points, coming up with the equation of the line.
Okay. So
2 points.
-9, comma -3, and 7, comma -7.
What's the most important thing about a line?
It's straight.
Slope. It's slope. So that's always the first thing you want to do, is figure out the slope.
Okay.
How do I get the slope?
Rise over run. So
What is it in this case?
in this case, it doesn't matter which order you do it in as long as they're the same.
Yes.
So you could do -9.
Got to do the rise first. Negative
Okay,
9
so
is part of the run.
right. So -3 plus -7.
Got to, okay. It's -3 minus a -7. It's subtraction always.
Okay.
In other words,
Over.
difference of the y coordinates, which is what that is, over
Right.
what?
The distance of the x coordinates.
Which is what?
-9 minus 7 in this case.
Yeah, I would not be able to reverse that and say 7 minus a -9.
Right.
In other words, you got to go the same direction in the numerator and the denominator. Well, the numerator is +4. The denominator is -16. So your slope is -1/4.
Okay.
Now that you have the slope, there are various ways to finish the problem. Probably the way that most people prefer to do it is using y equals mx plus b format. Well, we know what m is,
And you can plug in an x.
and I can plug in either point for y and x, and that will solve for b. So pick the simplest point to use.
Let's do 7 and -7.
So tell me what to write.
So -7 equals -1/4 times 7 plus b.
And now that's going to let us solve for b, because that's the only unknown. So let's see, what is that? -5 1/4 equals b. So now we have the whole equation. We got y equals -1/4 x minus 5 1/4. There's the equation of that line.
Okay. What is b? B is the y-intercept?
Yes.
Okay.
Okay. Now, there's another way to do it. I'm not going to give it to you because I don't see any reason in confusing the issue. What was I going to say? Can't remember. Yeah. This is the reason most people prefer this method is because if you say to most people, what's the equation of a line, they're going to give you this format.
Right.
There is another format called point slope.
Point.
Yeah, and actually point slope is a little bit easier here. And I'll show you why. If we use point slope, well, once I got the slope, point slope looks like this. Y minus y sub 1 equals the slope times x minus x sub 1. And I only need one point. I don't need, I'll use the same point, 7 minus 7. So it's y minus the y-intercept is, or not the y-intercept, y sub 1 is -7. The slope is that, and it's x minus the x1, which is that. And that's actually an acceptable answer. I mean, you might want to simplify that left side so that it's y plus 7, but you don't need to put the answer in slope-intercept format. It doesn't have to be in y equal mx plus b. Which means if you can use point-slope format, it's a one-step plug-in. Notice that when I used y equal mx plus b, I had to solve for b. I had to do some math. Well, if I use point slope, I don't have to do any math at all. I just got to plug in a point, pick one of my 2 points, and plug in the y value for y sub 1 and the x value for x sub 1, and what you get is the answer. Now, you might say, well, that doesn't look like that, but it really does, because what I have is y plus 7. If I distribute that, I get 1/4 x plus 7/4. Now I subtract 7 from both sides, and I get the same thing I got when I did it the other way.
Yeah.
And either way is acceptable. It just is whatever you're most comfortable with. Probably the quickest way is point slope. If
Okay.
given a point and a slope. In other words, there's two quintessential questions in algebra. One is they give you 2 points and they want the equation of the line. The other is they give you the point and the slope and they want the equation of the line. So
Okay.
either one, you can figure out the equation of the line. But if you are given the slope and 1 point, boy, this is awfully easy if you know that format.
Well, that's the next question. Give me a slope and a point.
Okay, I'm not surprised. So what's the slope they're giving us?
2/3.
And the point?
4, 1.
Let's use point slope format, just so you see how easy it is. And then we'll use slope-intercept format, and you can see why it's tougher. So what's the general format of point slope?
Y minus y sub 1 equals m times x minus x sub 1.
Now, let me give you a little help for memorizing this in case you forget. Notice
Okay.
what m is. M
So-
is the rise divided by the run.
Okay.
Okay? So if you ever forget it, know that if I divide both sides by x minus x sub 1, I've got slope equals the difference in the y's over the difference in the x's.
Right. Okay, yeah.
So that's an easy way to make sure you got that right. Now, the answer is one step. Plug it in.
Y minus 1 equals 2/3 times x minus 4.
And that's the answer. You don't need, unless they specifically said, give us the answer in slope-intercept format. If they just said, give us an equation of the line, this is your answer.
Well, this says to graph it.
Well, okay, that's a little different. This is a little harder to graph when it's in this format.
Okay.
In other words, if I want to graph it, I would rather it be in slope-intercept format. So
But then you could just distribute and take it there,
yeah,
right?
exactly. In other words, let's manipulate this. That would be minus 8/3 plus 3/3 minus 5/3. I believe. Be minus 8/3 plus 3/3. Yeah. So there's the equation in slope-intercept format.
Wait, what's happening? 2/3 times 4 is 8/3.
Negative 8/3.
Negative 8/3. So you have y minus 1 equals 2/3 x minus negative, minus 8/3.
Correct? Then you,
So
bring,
you have 5/3.
then you bring the 1 over. Okay.
Oh, plus 1. Okay, so y equals 2/3 x minus 5/3. Gotcha.
Correct. Now, the reason I wanted to put it in that format is because I know how to graph that real easily. How do you graph that? Where do you start?
You plug in the y-intercept.
Which is minus 5/3. That's where you start. And then what?
How? Minus.
That's the y-intercept. So we know that that point is on our line.
Right.
Now let's get another point. We can't graph it until we have 2 points.
It's not letting, like, it won't let me plug in 5/3 because it's just like a regular.
Think slope. Think slope. In other words, how do I graph the rest of this? I got to find another point.
Well, it tells me that it's passing through the point 4, 1.
Correct, but that's not, I don't need that to graph. Well, okay, I can graph that, I guess. I can go up here to 4, 1 and connect the 2 points. So there's the graph of the line. But the other way is I got a slope of 2/3. What does that mean? That means I go up 2 and to the right 3.
So up 2.
There's the line. In other words, I don't need that other point. I needed it to come up with the equation of the line, but I don't need it to graph the line.
Okay.
But that's actually the quickest way to do it, is the way you did it. In other words, as long as we know that it crosses the y-axis at minus 5/3, and we know it goes through the point 4, 1, well, just connect those 2 points.
Okay. So this next
2 points define a straight line, always, no
right.
matter what 2 they are.
Okay, so this next one is, it wants me to write an equation in slope-intercept form for a line that has a slope of -3/2, and it passes through the point 10, -2.
All right. You got 2 choices. You can use the point slope format and then just expand it so you get y equals something. So you get slope-intercept as a final format.
So slope-intercept is standard form?
Yeah, there's actually 2. They're both standard. I'm not sure one is more standard than the other.
So y equals mx plus b is slope-intercept.
That's slope-intercept, is y equal mx plus b. It's slope-intercept because we have a slope and we have the y-intercept.
Gotcha.
If the other is point slope format, and that we have a point and we have a slope. So you could use either one as long as you end up with this one. The advantage of using the second one is that I get my equation immediately, then I just have to rearrange it. The advantage of working in slope-intercept the whole way is that I got to solve for b. How would you solve for b? Let's work in slope-intercept the whole way.
Okay.
So y equals, the slope is -3/2 x plus b. Now what?
So y minus -2.
Okay, we're going to use point slope then.
Well, yeah, I worked it from point slope.
I was going to solve the whole problem using slope-intercept.
Oh, okay. I mean, personally, I actually find using point slope easier right now.
That's fine. That's absolutely fine. If that's what you find easier, let's do it.
Okay.
In this particular question, because they want the answer in slope-intercept, I'm not sure that it's any quicker to do it this way.
No, but it makes me more sure about it.
That's fine. Absolutely fine. I'm never going to try to convince you to do the other. It's not faster. It's just most people are more comfortable with slope-intercept. So what's the rest of
it? It equals -3/2 times x minus 10.
Okay, now that's not an answer because we need the answer to be in slope-intercept.
So y plus 2 equals -3/2x plus 30/2.
So what's the final answer?
So your final answer is y equals -3/2x plus 13.
Yeah, and we had to do quite a few steps there. In other words, we had to plug it in and then we had to simplify it. Would have been
Right.
about the same number of steps had we not worked with point slope at all and done everything in that format, and we would have just substituted that point for the y and the x, and we would have solved for b. About the same amount of work.
Okay. So now this next one just wants me to write it in point slope form. So
Okay.
so slope intercept is y minus y sub 1.
Oh, that's point slope. Slope intercept is y equal mx plus b.
I was writing point slope.
Oh, okay. You said, I heard slope intercept. Sorry.
Oh, no, that was an accident.
Okay.
Slope intercept is y equals mx
Correct.
plus b. Okay, so it wants me to write this one in point slope. So that's, I'm just going to plug it in from the start. So y minus 4, because the point is negative 10 comma 4.
Okay.
Equals, the slope is negative 3 over 2. Times x minus 4. No, negative 10, sorry. X minus negative 10.
Almost got it. I almost fell for it.
So, negative 3 over 2x and so minus 30 over 2, which is 15, plus 4. So y equals negative 3 over 2x minus 11. But wait, now I'm back in now I'm back in slope-intercept form.
Oh, that's right. My mistake. I wrote it down so I wouldn't forget it, and then I got lost. This is the answer.
That's the answer.
For point
Not the next step?
Either one, but this would be an acceptable answer. Well,
Okay.
you'd want to make it x plus 10. You wouldn't want to leave the x minus a minus. But yeah.
But do you want to distribute the
I don't
x?
think you want to. No, I don't think so. I think if they said give it to me in point slope, this is what I would give them. No need to do anything more. Not at all. Because this is what happens is when you do point slope, this is what you get. This is the format you get. There's no need to change it.
So the answer is y minus 4 equals negative 3 over 2 times x plus 10.
Correct. This one right here.
Okay. So now it's telling me, so the line is 8x plus 4y equals negative 4.
Okay.
It says, what is the slope of a line perpendicular to this line?
Okay. So first of all, we got to figure out what the slope of this line is.
Okay.
What's the best way to do that?
Isn't it 4 over 8?
Solve it for y. In other words, if I solve this equation for y, I'm going to have it in slope-intercept form.
Okay.
So I'll know the slope.
So you got 4y equals negative 8x minus 4.
Keep going.
Divide by 4. Y equals negative 2x minus 1.
What they want to know, just the slope?
What is the slope of a line perpendicular to this line?
Okay, there's the slope of this line.
Perpendicular.
What's the slope of the perpendicular? You got to do two things.
It's the opposite reciprocal.
Okay, so what is that?
Positive 1/2.
Yeah, if you always remember, you got to do two things. You got to change its sign and you got to flip it.
Right. So parallel has the same slope, correct?
Correct. A line with the same slope might be y equal minus 2x minus 3. That's parallel to this line. Notice they have the same slopes, they just have different y-intercepts.
Okay. Same slope. Okay. So find the average rate of change.
Another word for slope.
Okay. So g of x equals negative 2x squared plus 8. And it says from x equals 3 to x equals 8.
Okay, so if I want the slope to rise over run, remember average rate of change means slope. Okay, well,
Okay.
the rise? The rise is g of the big number minus g of the smaller number, the first number. That's the rise. The run is 8 minus 3. Now,
Wait.
tell me what g of 8 is.
G of 8. Oh, okay. I get this. So, sorry, let me write what you're doing down. So m is equal to rise over run.
Mm-hmm.
And that's equal to g of 8.
Which is the y value when x equals 8.
Minus
the y value when x equals 3.
over 8
That's
minus
how
3.
that is the rise. And the run is the change in the x values. So I got to figure out what g of 8 is, and I got to figure out what g of 3 is.
So g of 8, so negative 2, 8 squared, plus 8.
Minus 128 plus 8. So g of 8 is minus 120. What's g of 3?
128? 64 times 2?
Plus 8.
128 plus 8.
Minus
Right, so negative 120.
You see why it's minus 128?
Yeah, because of the negative 2.
That negative's not being squared. Only the x is being squared.
Right, yeah.
The x is 8, so 8 squared is 64, multiplied by minus 2 is minus 128.
Right.
And
Now negative 2
minus
times...
Okay,
so
now what's g of 3?
Negative 2 times 3 squared plus 8, which is negative 2 times 9 plus 8. Negative 18 plus 8, so negative 10.
Okay. Now let's
So
fill in this. G of
negative
8. Go ahead.
negative 120 minus 10 over 5.
Good. Way to not drop a negative sign. That's exactly what you wanted to do, is make sure you get every single negative sign. Well, what is that? That's minus 110 over 5, which is minus 22. That's the average rate of change. For every time x moves to the right 1, g of x drops by 22.
So 110 divided by 5 is negative 22.
Is negative 22, yes.
So then you get a negative 22. And that's the answer. Okay.
Pretty steep slope, but if you think about it, we're looking at a parabola like this. Opens down because it's got a negative in front of the x squared. And they want the average rate of change between 3 and 8. Well, that's a pretty steep slope.
Right.
Negative. So negative 22 makes a lot of sense. In other words, if they wanted the average rate of change between negative 1 and plus 1, it would be 0. That's a zero slope.
Okay.
Whatever the slope is between the two numbers they're talking about.
Gotcha.
Might have time for one more.
Okay. Wait, so the answer is negative 22.
Yes.
So this is graph the function.
Okay.
2 times the square root of x minus 1. It says to do so, graph the leftmost point and 3 additional points.
Okay. Is it y equals this?
Yeah, f of x equals.
All right. So they want you to graph this by making a table, which is not a method I'm particularly fond of, but it works. Pick 3 points for x. They said from the left, right?
Yeah, graph the leftmost point.
What's the leftmost point?
1.
What's y equal to when x is 1?
Y is equal to 0.
Pick another point.
2.
What's y equal to when what's y equal to when x is equal to 2?
2.
And one more point?
I have to do 3 additional points, so I have to do 2 more points.
Okay. Pick good numbers.
Right, so let's do 5.
Good. That's what I was getting at.
Which gives me 4.
Okay. By picking good numbers, I mean let's avoid fractions if we can.
Right.
Or irrational numbers.
So then you have, let's do 10. That gives you 6.
Mm-hmm.
And then let's do 15.
How about 17?
17 works. That's what I meant.
I know. And that gives you 8. Okay. So all we do is graph those points. There's one of them. There's 1, 0. There's 2, 2. There's 5, 4. There's 10, 6. And there is 17, 8. And you'll notice what you're looking at is the square root function.
It's telling me 17, 8 is out of bounds.
17 gives you the square root of 16, which is 4 times 2.
Oh, no, but I already have enough.
Oh, okay. So you gave it 1 point more. That's why it didn't like it. It only wanted 4 points?
Yeah.
Okay.
All right. So we could be done for today. We only have 7 more questions before we're done with this practice test.
Okay. And we got a session tomorrow morning at 9 o'clock my time?
Yeah, and I think
we got 2 of them tomorrow.
Yeah, I think we have 2 tomorrow.
Okay, so we got one at 9 my time, which is 11 your time, and we got another 11 my time, which is 1 your time.
Okay.
Sounds good. I'll talk to you in the morning.
All right. Yeah.
All right, Max. Bye-bye.